Hello. Welcome at the additional session. Hello. Hi, Heather. Hi, Josh. Jonathan, Remy. Thank you. Thank you for attending. Because I hope it will be really short, because we still have, I think we have 2 or 3 shapes of the polar curves, and I will just go through and then I will let you go. Okay, that means we did finish yesterday the session with this shape, which is cardioid, and we kind of I hope we learn how to effectively read this formula. That we can go through theoretically 360 angles and compute each radius, but looking at the graph and kind of drawing and see how the radii behaves, we can also plot the points. Okay, that means let's do the next one. But before I change the slide, before we go to the next formula, we may notice, looking at just at the graph, the Cartesian graph, down here, radius r equals to 1 plus sine theta, and we can see this. That's the curve. It's just the sine curve shifted 1 unit up, and we may notice that the entire graph is placed above the x-axis. Yes, which means each point, each value of the function is positive, and respectively each radius, the distance, will be positive. And then plotting the points on the polar curve, I will have points in each quadrant, because each quadrant is positive. Because we remember, as soon as the values are negative, we will not plot the points there. Okay, that's also maybe a good feature to realize and then adopt. Okay. That we know cardioid, and okay, we did this, and I think I do have the solution step by step. Okay, and then we have the cardioid. Just maybe one, I think I did tell you this, but the cardioid will have the formula A plus or minus B sine theta, or plus or minus b cosine theta. And if A is exactly the same like the coefficient B, then we always have the cardioid. Now what we will do, we will take this similar formula and similar shape, but the coefficient B will be bigger, greater than A. And, oh, okay. This will be the next one. Okay, I also have this one. It's fine, because that's the other one. I really thought that I have maybe I can, it's okay. We can do this one. That means this is the other shape. I thought that I have with the coefficient greater, but this will be after this one. Okay, that means the next shape after circle and cardioid is also this. And this will be sine, oh no, wrong. I can write sine n theta or cosine n theta. And at the moment, we will start with cosine 2 theta. Right? That means all of them, and then I can have sine or cosine, and I can have a multiple, I will have a coefficient of theta. That means I can have 1 theta, 2 theta, 3 theta. Actually, if it's n equals to 1, we know the shape. Do we know the shape from yesterday? Just 1 theta, sine of 1 theta, or cosine of 1 theta. Do you remember the shape from yesterday? It's just the circle. This one will be in the first and the second quadrant. This one will be first and the fourth one. Yeah. Thank you. Okay. That means we know this one now, how the multiplicity of angle, how this will affect the shape. That means let's start with 2 theta and let's start with cosine. And the same thing will be much, much easier if I will see the graph of cosine 2 theta. And I think I do have the graph of cosine 2 theta, just the Cartesian graph. And that we can see cosine 2 theta means that I have to draw cosine curve twice between 0 and 2 pi. That means this is my one cosine curve and then the other cosine curve, because the period is just pi, not 2 pi. Okay, that means this is a really nice graph, which of course x-axis represents the angle and the y-axis, the height, represents the value of the function, and value of the function is radius. And now let's divide. That means from 0 to pi over 2 is the first quadrant. Between pi over 2 and pi, the second quadrant, because I have to kind of see how this behaves. And the fourth quadrant, the last part. And let's also see the zeros. The zeros are at 45, 3 pi over 4, which is 3 times 45, 5 times 45, 7 times 45. That means that's zeros, which I will plot some points, but at these angles, I have to come back to the pole. That means I will draw it. Okay, I can keep that. That's the main angles. And now I believe the 45 will be important. 45, 45, 45, oh, and 45. Okay. Because for these 45s, we will come back to the center. Okay. And let's start. Let's start drawing. Maybe I will use the green color. At 0, okay, at angle 0, the radius is 1. Okay? And let's see what's happened. Between 0 and 45, my distance, which is the radii, I will minimize. That means I will start at 1. Let's say this is 1. Okay, and then I will draw less, and less, and I will reach 0. Okay, that means I will plot the points here. Okay, now what's happened? Now we can see it's a little bit, we have negative values. Everything what is below is negative. Between 45, pi over 4, and pi over 2, all of the values are negative. That means that's negative. I will not plot any points here. I will plot the points in the opposite quadrant, which means I will start from 0 and I have to increase the magnitude. I have to increase my radii at pi over, we can see at pi over 2, the value is -1, which means it's 1 at 3 pi over 2. Okay, that means I will increase, and reach 1. Okay, and then from pi over 2, I will decrease and reach 0. Again, on this side. That means I will go this way, 0. And then symmetry is a rose. Yes, it's kind of like a flower. I will go, yeah, it's a beautiful flower, but let's see because we will just do this one. And I can tell you, I mean, you will probably realize the pattern and then you will know all of them. Sine, cosine, 2 theta, 3 theta, 5 theta, 4 theta, 10 theta. You will know how the rose looks like. But let's go through this one. Okay, that means I'm here. Between 3 pi over 4 and pi, it's positive. That means I will be on this side. That means I have to increase up to 1. And then decrease to 0. Okay. And then again, this is negative. Which one is negative? That part. That means I will not plot anything here. I will plot in the opposite quadrant, which is actually here. Yeah, that means I will go and plot here and then come back to 0. And then the last part is positive, and I will come back to this one. It should be nice symmetric loops. But yes, it's just that we call rows of flower. I don't know even if we have like a special name for this one. We have for the cardioid, of course. Okay, that means this we can see we do have, we did have cosine of 2 theta, cosine. Okay, let's see, cosine of 2 theta, 2. And how many loops we create? Can you see? We did, yeah, yes, we will try to determine how many like petals we have, like loops I can call. That means we can see how many loops, how many of this, yeah, petals I can say, 4. That means what we did, we kind of like double this. That means this will be the case always for the even number. When we will have cosine of n theta and n is even, okay, we will always see twice as many as this number, twice as many of these loops. 2 theta, we will see like 4 petals. If it's like, I don't know, 6 theta, we will see 12. If it's like, I don't know, 20, we will see 40. We will always double. Okay? We theoretically, we did, okay, we did double. We did double, yeah. Okay, that means that's the case for the even number. And one more thing, you can also see on the x-axis, we do have the 1 values, because cosine at 0 is 1, and cosine at pi, of course, is -1, but yeah, it's also, it's on the other side, but it's on the x-axis. That means we will always see we do have values on the x-axis. Yeah, it's not like we do have the curve intersecting. Okay, now let's look how sine 2 theta looks like. That means that's the cosine. And we can see it's the 4 leafed rows, or like 4 loops. But we can see it, we can easily recognize because it's cosine. We do have values on the x-axis. For the sine, 2 theta will be similar shape, but we will have no points at x-axis. Okay, that means I do have another one, sine 2 theta, and we can follow the same process. However, okay, we know how many loops, how many petals we expect. Can you tell me? Of course, 4, because it's even number 2, we expect 4. And what about sine at 0? If I think about like just the value, sine at 0 is 0. Sine at pi is 0. That means x-axis, we shouldn't, like the loops, the flowers, they shouldn't intersect. Yeah? For the cosine, yes, but not for the sine. Okay, and I do have graph, but a little bit, no, it's still good. That means this will be pi, that's pi over 2. This is 3 pi over 2, and that's 2 pi. Because I need 2 sine curve squeezed between 2 pi, because it's the period is pi. Okay, and of course, in the middle, we will have pi over 4, 3 pi over 4, 5 pi over 4. That means we still kind of need 45, but we need 45 not for zeros, we need for the maximum value. Okay, that we can see, we will start from 0, reaching 45, it will be 1. This means it's the same shape, from 0 to 1. Then from 1 to 0. Oh, too fast, because that's the exercise for you. And then, okay, 0. Now, between, this is negative, that means I will plot everything in the opposite here, and I have to come back here. And then, where I am here, then I'm between pi, here, 1, and 0. And then again, everything is negative here. That means I will plot in the opposite. I will reach 1 and 0. Okay, That means it's the same shape, everything is the same, but it's shifted because of course the sine value. And you can see, do we have any intersection with the x-axis? No, because that, thank you for answering. That's how we actually recognize the difference between sine and cosine. That's me now. I have really nice exercise and I want you to give me all of the formulas. Look at this. Because we didn't do one thing. Let's come back. If, because we did even number, if the n, the coefficient n, is an odd number, the number of loops will stay the same. Okay, that means when we will have sine of 3 theta, we will see 3 pedals or 3 loops. Theoretically, we kind of tracing twice. That means theoretically they are also double, but we trace the same like points. That means we don't really see as a final output as a double. That means technically when we see the odd number, sine of 3 theta, 5 theta, 7 theta, or the same cosine, we will see the same number, exactly the same number of loops. Okay, and we know how to distinguish the difference between sine and cosine. Yeah, sine has no values on the x-axis, no intersection. Okay, that means now all of them will have this formula. I mean, some of them sine, some of them cosine, and you have to determine which one is cosine, which one is sine, and number, I mean, the value of n. Okay, let's see, 1, 2, 3, and if you can give me the correct equations, then you know all of your flowers. Okay, what about the first one? Get ready and type, and I will retype it. It's cosine of 2 theta. Yeah, you can say t or q. You don't have to type theta. Okay, but it's definitely cosine. Okay, I will put, and it's definitely 2. Really good, because we can see we do have. Okay, what about number 2? How many loops we have? Yes, we have 1, 2, 3, 4, 5, 6, 7, 8. If it's 8, it means that we did double number 4. And it's still cosine? Yes, because we can see we do have values, we have intersection. That means it's cosine of 4 theta. Really nice. Okay, what about number 3? It's still cosine because we can see we have intersection and it's the same number. The n will be the same number as the numbers of the pedals or loops or yeah. Look, I was looking for different synonym. Okay, that's meaning good. Okay, number 4. You will not make the mistake. It's cosine, really good. Oh, I should mix them a little bit, but no, it's okay. It's cosine, and it's 1, 2, 3, 4, 5. We will not change the number. Cosine of 5 theta. Yeah, perfect. What about number 5? It's sine. We just did sine of 2 theta, of course. What about number 6? It's sine of, because we can see no intersection, no no points on the x-axis. It's sine of 4 theta, because we did double, we have 8 loops. And number 7, yes, sine of 3 theta. And the last one, sine or cosine, sine, and it's 5. Okay, that means that's this one, okay? That's another type of the curve. And I can give you a question like that. I can maybe give you the list of the equation, list of the pictures, and you can match. Okay, that means I think we have one more. The similar to the cardioid. Yes, that's the one. Okay, we have to be, I will try to go through with you. I should maybe ask some Desmos or some programs, but yeah, let's do the old-fashioned way and let's draw it. That means we can see now the equation is quite similar to the cardioid. Yeah, because we do have still the form R equals to A plus or minus b, and sine, cosine, we do have sine in this case. But in this case, just the absolute value, because I will not involve plus or minus, just the coefficient b is greater than a. And we can see 2 versus 1. Okay, that means when you will see that the coefficient in front of the trig function, the coefficient b is greater, then the shape is a little bit different than just the heart. Okay? Similar, but something extra. Okay, that means would be so helpful to have just the Cartesian curve. That means like y equals to 1 minus 2 sine theta. And I think, let me try. We will start with sine theta. I mean, I can, okay, sine theta. That means sine theta looks like that. Okay, let's do step by step. Okay, that means sine theta. Multiplying by 2, we will multiply each value. That means 0 multiplied by 2 will stay 0. This value, of course, is 1. That means 1 will become 2. Okay, 0 will still stay 0 because 2 times 0 is 0. This negative value will become negative 1 times 2 will become negative 2, and 0 will stay 0. Okay, that means the higher graph is just, I will erase this one. The higher graph is just 2 sine theta. Now the negative is affecting that I will switch the graph. Everything what was above will be below, everything what is below will be above. Perfect, I can erase this. Okay, and now the only last step that I have to do, which I almost have, I have to shift 1 unit up. That means 0 will be here at 1, 0 plus 1, negative 2 will become negative 1, okay? And then 0 will become 1, positive 2 will become positive 3, and 0 plus 1 is 1. Okay, that means my graph, and I can use different color, will be like that. And I believe I do have, okay. Okay, that's because this height, the blue curve, will show me the radii. Before I erase, oh no, I can erase the curve. Okay, but I do have my nice, that means this is pi over 2. Yeah, it's better. That's the first quadrant, that's the second quadrant. This is 3 pi over 2. That's the third quadrant. And the last one, of course, is the fourth one. Okay, we don't even have to look at the bottom graph. Okay, that means the curve, the blue curve represents the graph and represents the height of the blue curve, will tell me how the radii will change. We may notice this, zeros. Okay, and these blue dots, like whatever we will plot the points, we have to get back to the pole, to the origin. And we can easily find these values because I can say that my graph 1 minus 2 sine theta is equal to 0. Then solving for sine theta, I have 1/2. And this means that the theta is, oh, you can maybe help me. Sine for what angle? Is 1/2 for 60. I mean, no, for 30, pi over 6. That means this is pi over 6, and this will be the second quadrant, 5 pi over 6. Okay, that means I really need to draw. Now let's get the shape. Okay, I need 5 over pi over 6 and 5 pi over 6 because I shouldn't have any points, any intersection at these 30 degrees, pi over 6 and 5 pi over 6, because we can see it's zeros. We have to get back to 0. Okay, now let's start. I will take a green color. At 0 degree, the radius is 1. And we can, and I have to decrease. That means from 1 to 0. From 1 to 0. Oh, a little bit. Yeah, I can tell you it's not, it's okay, from 1 to 0. Now, between pi over 6 and pi over 2, everything is negative. But in terms of the magnitude, in terms of the absolute value, I have to increase the radius from 0 to 1, because this is negative 1. It means from 0, I will not plot anything here for now, because it's negative, but I will plot in the opposite. Okay, from 0 to 1. Oh, I need actually green color. From 0, we can see here up to 1. 1. And then the same, symmetrically, from 1 to 0. From 1 to 0. Oh, we don't need that. Okay, now I'm here at the pi over 6 times 5. I have to, now let's see what's happened. At pi is 1. That means I have to increase to 1. And then from 1, I have to indicate 3 at 3 pi over 2. 3. Yeah, I have to increase from 1 to 3. And symmetrically, from 3 reaching pi over 2, I have to have the radius 1. Okay. It's okay. That means the shape supposed to be the nice cardioid with the loop inside, because we can see that loop for the negative part. Yeah, we can see the negative part below. I didn't draw anything here and here, my question marks, because it was negative. I draw it here, the little loop. Okay, and the name for this came from French language, and we can, most of the mathematicians, they will say cardioid with the loop, or we have a special name and we will call Lima, I think it's limaçon. I don't know if, I don't know French, if you know French. It's like Lima, yeah, Lima, because the C has like a little comma. Yeah, I always call limaçon. Probably can you put the microphone on, somebody, and tell me that's the, oh, okay. Okay, that's the C with the comma. How do you say cedilla? I think French is beautiful. I don't speak French. I barely speak English. No, but yeah. And if, as I said, I think, yes, the cardioid is easy for me because came from Latin. Thank you, Heather. Okay, so yeah, I like the French. Yeah, but I think, do you think limaçon, probably the N is silent? Yeah, okay. But that's the shape. And now let's play the game like we did yesterday. We may have the same, like 4 different orientation of the limaçon. We may have this way, or we may have, that's all of them. And we can see that the only difference is sine, cosine, and plus or minus. But we can nicely see the coefficient in front of the trigonometric expression, trigonometric function, it's greater. That means this is the general equation, looks the same like for the cardioid, but in this case, B is greater than A. Okay, then is limaçon. Okay, and you remember when we have more points on the x-axis, like wider on the x-axis, is always cosine. B, C, and D, 1, 2, 3, and 4. That's also the exercise. What if, okay, if A, yeah, we don't, it's kind of like, okay, Heather is asking what's happened with the graph. I think our textbook is not covering this type. Jonathan is saying it begins to look more like it's kind of like, yes, if A is greater than B, we can kind of imagine that this loop is getting smaller and smaller and is pushed out. That's mean, yeah, it will kind of like, yes, it will look like a circle. It will more like smooth, or even like make a little bit like bump. Depends, of course, what is the difference? Yeah, but good question. But we will not cover this. I mean, because it's not really in your textbook, I can always add. But yes, you're right, Jonathan said. Yeah, it will look like, and also, of course, good question, Heather. Because we can, based on the trick graph, which I will not do it because I did one. Yeah, will be more like circle, like with a little bit like bump. Okay. That means, please tell me, A and B, no, B and D are the cosines or sines? B and D are the cosines, okay. That means they are definitely cosines, which yellow. And can you tell me which one is which? It will be 1 plus or minus cosine, 1 plus or minus cosine. We know that it's cosine. B is plus, because cosine at 0 is 1, and then we will, 1 times 2 is 2, 2 plus 1 will give me 3. That means it's nice and easy to see that this is 3. And this is, of course, minus. Good. Which should be positive. Okay, B and C are definite, A and C are the signs, but can you tell me which one is positive, which one is negative? 1 plus or minus sign. A is plus, this is minus. No, I think should be the other way, because we just did. Right? We did the minus because I was flipping. Okay. Yeah. We can always check. Yeah, like what we can do. I think 90 is good. Pi over 2. Let's check this equation. If sine at 90 is 1, 2 plus 1 will be 3. Yeah, that's that. Yeah. Thank you. And we can do the same for 3 pi over 2. Negative 1 will give me positive 2, 1 plus 2 will be 3 at pi over 2. Yeah, yeah. Always the top 2 quadrants, so that is little, yeah. Yeah, we can, with trigonometric, we can always find lots of tricks, like patterns and observations. I think I remember that description, that word from yesterday. Okay, that's the last shape. Do I have, let me check. Oh yeah, that's the cardioid. Yeah, we remember. That means this is the same equation, just in case. Yeah, sometimes you will see this relation, but of course this means that A is the same. Because what's happened, A and B is the same. That means it could be like I can have 2 and 2, 3 and 3, 4 and 4. I can have any number, not necessarily 1. But I do have 1. Joshua, that's, I think, with the coefficient A greater than, what's the shape? Oh, I think, I don't even know. Oh, the volume of Descartes, that's just the loop. We did, that's more for the, oh, no. Oh, okay, I do have, let's do one more shape. But now, let me, one thing, we will, oh no, let's just do, I think the volume of Descartes, what Jonathan is asking, I think we have just the Cartesian equation. I don't even know the polar equation. Yeah, Jonathan, where do you, I think it's just this equation, x cubed plus y cubed, 6xy. How do you remember the name? Yeah, that's the volume of Descartes. I don't know if I'm pronouncing correctly, but that's just the Cartes, that's the, okay, that's you're taking the advantage of the French. And I think the loop, oh, I don't remember. Yeah, it's something like this. Ah, that means it's, I see. It looks maybe like one loop. But yeah, we will not do, which is, yeah, I have to remember. I didn't even translate this, but volume of Descartes is, we do have the Cartesian equation. We will not do the polar. Yeah. Oh, nice. You know some. Okay, let's see if you will answer this question, if you will see maybe on the final, A, B, C, D, E, and the equation is 1 minus cosine theta. Do you think you can tell me which equation, which graph represents this equation? Which one we can eliminate? Okay, oh, Anton is telling us B, we will find out. But which one is definitely not true? Which one we can eliminate? We can eliminate C, and I think we can eliminate, okay. Oh, you even, okay, that's when you even saying C and E is obvious because it's not with the loop, because we do have one cosine, 1 minus 1 cosine, A and B is the same. And who said D? Joshua said also D, because D, I think, represents sine. Yeah, 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 good. That means A and B represents cosine. And yeah, do you think you can say that B is the right one? 1 minus cosine theta. For the 0 degree, that's what you can do on the test if you really lost, but I know that you will be more than good. 3 pi over 2 and 2 pi. We can just check if we have the same points. If cosine at 0 is 1, 1 minus 1 is 0. Perfect, 0. Cosine at 90 is 0. 1 minus 0 is 1. Okay, we did go to 1. Pi, cosine at pi is negative 1. Negative 1 times negative is positive 1 plus 1, 2. And perfect, I reached 2. 3 pi over 2 is 0. 1 minus 0 is 1. That means we did, come back to 1. And 2 pi is the same like 0, which is 0. Yeah, makes sense. This will be, B will be the correct answer. That you can see, I always, of course, we do know the shape roughly, but we can always check these 4 reference points, especially for limaçon or cardioid. I do, I just wanted to show you, I didn't finish this, but you can see we may have 2 and 4. Yeah, that's the same. It doesn't really matter that it has to be 1 or 2, but this is B, the coefficient B is greater, then of course is this. I just, oh no, okay, we will not do this. I have one more, maybe a little bit for fun. I will not tell you what is the shape, but what do you think? R equals to theta. What do you think? Like you can maybe try to think, or maybe you saw that graph. Doesn't really, I mean, we do have a name, I believe, but what do you think? Like what will be? Okay. Yeah, that we can try, of course. 0, 90, 180. Of course, would be nice if I should maybe give you as a homework assignment. Would be nice if everybody will think on its own. But it is kind of like oh, it is on the web assign. I didn't want. It's like a seashell. Yeah. Oh, I didn't really want. I always assign the shapes that we have to cover, like cardioid, limaçon, circles, that's important, and the flowers, of course. But this one, of course, this one is like a spiral, because we can think if the radius, as soon as the angle increase, the radii increase. That means for the 0 degree is 0. Yeah? For the 1 degree, if I will have like all of them, for the 1 is 1, for 2 is 2, and for 90 is 90, and then it's bigger and bigger and bigger and bigger and bigger, and I will have bigger, and of course I will increase the angle, and then the distance from the center, from the pole, will be bigger and bigger. That means, yeah, it is like a seashell, or actually I can draw it normally. You can try to plot, but yeah, that's actually good guess. And we can go over and over and over again. But yes, it's also, but I didn't, okay, I will check if it's on the, I mean, now you know, but I didn't really intentionally wanted to have this question on the website. Okay, that's all of the shapes. If you will find out some other shapes that you're not really like familiar, please let me know. But definitely the weekly quizzes and the homework assignments should include the standard shapes. And yeah, that's actually, yeah, that's everything for Mat 141. What you can do, can you actually put your names on the chat box? I think I know, but just in case. Most of you has the full name as a login name, which is good. Just, yeah. Because we can treat this as a recitation session. Yeah, okay, okay. Yeah, because you help me, you always, yeah, you always participating. And of course I recognize these names. Okay, that means let's finish. If you have any question, please let me know. But we will have a few final exam review session. Okay, that means definitely. Maybe I can do all of the evening sessions. Again, I know that we have different time zones, but maybe I can, instead of the morning, the lunchtime session, the Tuesday, maybe I can run in the evening if that's more helpful. Or I can maybe do the doodle like Heather recommended ones, and then maybe whoever, because I want more students to attend. Yeah, and we will go almost over all of the questions that you will see on the final. Okay, that means please don't miss any question on the review session. And I'm planning to do like around 2, maybe 3 review sessions. Yeah, and I want like all of the students to attend at least 1. Okay, and the rest of them you can just watch it. Was Heather? I know it's definitely too early for Abdallah. I know. Evening work best. I know, because okay, that means what I will do. I will send like probably. Okay. I will try to accommodate like everyone. Okay, that means maybe I can send a doodle poll and everybody will sign. I mean, just indicate the time that you are available. That means I will run around 3 sessions. Each session will be different. Okay, but you may just attend 1, because I like when the students attending and when I see the students. Okay, I will let you go. Have a good night, and yes, stay tuned for my final exam information. Okay, good night. Thank you. And thank you for the nice French language.